Welcome, Professor Bright here, and we're going to continue our study of trig and see a few more interesting properties and theorems related to them. So this video is going to look at law of sines and the area of formula associated with law of sines. And really we're going to talk about law of sines from a geometric point of view, and then later on we'll talk about law of cosines as well. So we'll also kind of state a premise for this whole thing. So as you can see, there's going to be 5 videos in this section. So when we've been studying trig functions, right, we've been talking about the unit circle and we've been talking about right triangles, but my question is, can we use trigonometric functions with triangles other than right triangles? So can we use trig functions in obtuse and acute triangles? So I'm going to look at one specific case, and it will be similar for the other one. I'm going to look at an obtuse triangle. So imagine we have this triangle here, okay, and so just scrap that part. Okay, I'm going to label the vertices as let's do this as B, this is A, this is C. That's a capital C, by the way. And then convention when we're naming triangles is to say that the opposite sides are lowercase letters. So this would be lowercase c, so opposite of A here is this, and opposite of B is this. Okay, so we have a triangle with side lengths and corresponding angles. Okay, so as we know, trigonometric functions, they work in right triangles, but they're not, they don't work in non-right triangles. So what do? That's where we get a little bit creative with geometry. What we end up doing is we can make any obtuse triangle into 2 right triangles by dropping an altitude from the obtuse angle. Okay, and so this would be now a right triangle, and so then here we can call this altitude h, and now we can apply the trig functions in each of these triangles respectively. In particular, if I look at, say, sine of B, we know this to be h, the altitude, over c, okay, and we also know that sine of c can be expressed as h over b. Okay, and now why did I choose these? You will see. I could solve each of these independently for h. So if I solve those, I get h is equal to c times sine of b, and similarly here h is equal to b times sine of c. That's capital C. Okay, and with these two equations together, since they are both equal to h, I can set them equal to each other. So c is equal to, c times sine of b is equal to b times sine of c, and then rearranging this, I can say that sine of b over little b is equal to sine of c over little c. And so what this is saying is that the ratio of sine of an angle to its corresponding side length is the same regardless of angle and side. And so similarly, you can show that this is also equal to sine of A over its side length. You can also do the reciprocal version, so you could, do the side length on top, angle on bottom, doesn't matter. But this identity here that we have created, this, in fact, my friends, is called the law of sines. Okay, so so the idea is that for a triangle with side lengths a, b, c, lowercase, and angles a, b, c, uppercase, this ratio holds. Okay, and this is going to be super useful in helping us solve different exercises, and we'll get some practice with that later on. Okay, while we're in this topic, I want to look at one other connection, looking at area. Okay, and I'm going to actually back up here and do it up here in the space that I have plenty of. So if I look at area, right, for any triangle, we know the area is 1/2 times the base times the height. Okay, and so in our example here, it's 1/2 times A times H, right? I mean, that's fine. But now remember h, I have two different expressions for h. So I could say that this is equal to 1/2 a c sine of b, or I could say this is equal to 1/2 ab sine of c. And so this is actually super interesting, because what we can say is that it is the area we can compute is 1/2 two side lengths, right, a and c, that are adjacent, and sine of the included angle. Same thing here, AB, and then sine of C, which is the included angle. And you could actually go on and show that this is the same as 1/2 BC sine of A. Okay, so this is yet another formula that we should keep in our back pockets. And this applies to any triangle, okay, and not right triangles, okay. Similarly, the law of sines, super important theorem that theorem, law, property, identity, whatever you want to use, that will be very useful in our exercises ahead of us. Okay, so we'll get some practice putting these into action in the next video.